The second main thing in OOP is called inheritance. Well, it has almost the same meaning that we have in our real world. Inheritance means that the children will get something from their ancestors or probably from their parents, right? So same concept is being implemented over here in OOP. So let's read about the formal definition, then we'll go for hands-on. So creating new class, so new class will be the subclass, or you can say the children class, or okay, based on existing classes, subclasses, or superclasses, or you can say the parent classes, inheriting their attributes and methods. Obviously a class has only two things, attributes and methods, so we can inherit these things. Promoting code reuse and hierarchical relationships. Obviously if I have defined a code in superclass or parent class, I want to reuse that code. I don't have to write it again. I'll give you an example. For example, here I have created a human class, right? Now I want to create another class in which these same attributes and these same methods, I have to use these things. For example, I need to create a class called student, right? Now we know that student is a human. Student will have name, student will have age, student will have print details, something like this. So why not? I will inherit all the information that is already written over here in the student class. So all I have to do is I'll have to mention human. That's it. That's how we can inherit it, right? And secondly, what I have to do is I have to define an init function over here, and a self will be here, and here I have to do just one thing, and that is I need to call the constructor or the initializer of the parent class, right? Let me just add a few more spaces. Okay, so here I'll say, how can I call the constructor of the superclass? I have to do nothing. I'll just have to say super dot init, and that's it, right? And I also need to pass the name and age over there. That I'll just copy and paste over here. We also need name and age over here for the student as well, and for the student we also need, let's say, marks of a student, right, for something. And then since this mark is a new variable, so for this we need to define a self dot marks over here, and we'll say marks. Cool. Okay, now and let's do one more thing. Let's write a print statement over here that will make sure that will make sure the student object is being created. Student object creating. Cool. Okay, and one more thing, let's create a print detail method as well. So we'll say print underscore details, and we'll just pass self into it, right? Now when I'll be printing the details of a student has name, age, and marks. We need to print three things. Two things are already being printed over here, so I'll simply say self dot print details, and let's just distinguish this function over here a little bit. So let's say print, or maybe let's distinguish this function, print underscore student details, right? Just for the clarity that which function we are calling. Okay, so here I'm saying that self dot print details, which means that this function will be called and these details will be printed. Now one detail is left, that is the marks of the student that we can print over here. So we'll say self dot marks. Cool. And here we need to mention that marks. Cool. Okay, now we have, if I run it, we are already creating two objects over here. Let's create a student s1. Okay, student. Okay, so student, what is going to be the name of student? Let's call him student. Oh, that will, okay, student. So that is going to be the name of this student. Age of student is going to be, let's say, 15, and marks are going to be, let's say, maybe 45, right? Okay, so I'll run it. So here we go. Human object creating for Zia, human object creating for Tom. Wait a minute. Why this human object is being created for the third time? Why? Because when we are creating a student, what is the superclass or what is the parent class of this student? That is the human class. And here we are calling the constructor of the human class, which means that this will be executed for the student class as well. Make sense? So that is why human object creating for student is also displayed over here. And finally, student object creating, the fourth line, that is this one, right? Okay, now here if I say h1 dot print details, h2 dot print details, that is the previous stuff. Now if I say s1, that is the student one, I say student1 dot print student details, and if I run it, here we go. Name of the human is student, age is 15, marks are 45. Now remember, this name and age attributes are being inherited by the student from its parent class, that is the human class. Yes, no? I hope it makes sense, right? And here we can call this method print details method as well for the student class. If I say print underscore details, it will only print name and age, because for the human we are printing only these two things. But if we'll say s1 dot print underscore student details, then it will print out all three things. Marks are being printed over here, and rest of the details are coming from this part. Cool? Okay, now here is your, you can say, assignment question. What you have to do is, we have inherited a student class from human class. Now you have to inherit a teacher class from the human class, right? And in the teacher class, maybe you can add a salary of the teacher instead of marks. Cool? And try to work with it, try to, you can say, play with it. Alright, so last two basic concepts of OOP are polymorphism and abstraction, right? So we'll talk about both of them here. Before we talk about polymorphism, let's complete the previous assignment that we started last time, the assignment that I gave, I assigned to you guys. So basically we had to create another class called teacher class, and human should be the parent class to that teacher class. Obviously a teacher is also a human. So so here we'll say teacher. Oh, why don't I just copy and paste this structure, because most of the stuff is going to be the same, right? Okay, so here I'm gonna replace it with teacher, and in replace of marks there's going to be salary, right? We are going to copy this, and salary is going to be created over here. Now self.salary, because a teacher will have salary rather than the marks, obviously. And here where we are displaying it, we are saying that print salary. Okay, and here we are saying print students details. We can make it print teacher details. Cool? Yeah, rest of the stuff is same. I hope that. And here we are going to create a teacher. We'll say T1 is going to be teacher. Okay, and what is going to be the name of the teacher? Let's say the name of teacher is going to be teacher. Cool. And teacher is 50 years old. Teacher's salary is how much? Let's make it $10,000. Cool. Okay, let's run it. Now here we go. We know that what is this? What are these 4 lines? Because we have already studied that. But what are these 2 lines? We are creating a teacher object over here, but it is saying that human object created for teacher. Okay, makes sense. And then it is saying student object creating. Why? Because here in constructor we did not change it. So let's change it. Now let's run it again. Oh great. So now teacher object is creating instead of student object creating again and again. Rest of the details you already know. let me add one more cell over here so that we can explain things more easily. So t1 dot, now if I say print teacher details, and if I run it, here we go. So it is calling the teacher object, and name of human and age of human is being borrowed, not borrowed, but inherited from the base object or base class or parent class or super class. All of these words are synonyms. You can call whatever you want. And then salary is 10,000 is being printed over here, right here. Cool. Okay, so that was the assignment, and I can link this assignment to our question that was polymorphism. So basically polymorphism is the ability to use a single interface. So we can use the same method to represent different data types or classes, enabling flexibility and flexibility and extensibility in code design. What do I mean by that? Well, I had to read this boring definition. Let's go back over here. Okay, so it means that we can have a method with a similar name. What do we mean by that? For example, here we have this method print details. It is same in the parent class of student and in the parent class of teacher as well. But if I call it for t1, that is the teacher one, it goes through the route of teacher. And if I call it for student one, let's say s1, and I say print student details, here we go. Now it goes from the route of the student. Now this is the flexibility that we have. We are calling the same method. We're calling this method from two different objects, and it is printing out the information of the relevant object, right? And not only that, we can also call exactly that method as well, directly, not exactly but directly. Here we go. If I say t1 dot print details, it will print out the details of the teacher object, and here if I say s1 dot print details, it will print out the details of student object, or you can say the student class. So this is the, you can say, the magic of polymorphism. And finally, last but not least, what is the abstraction? We have already covered it, but I didn't tell you where we covered it. So basically abstraction is simplifying complex systems by modeling essential features and ignoring unnecessary details, providing a clear and high level representation, which means that, for example, here we have created a human object, right? So we had to create a system for the whole school. So first of all, we created an abstract class, an abstract object, in which we had the details, we had only those details that are common in all the classes, right? So this is called abstraction, where you can mention all the common details. You can mention the high level details of your object or of your class or of any project. That is called abstraction, right? So that's about OOP. We had studied the main concepts of OOP, that are encapsulation, inheritance, polymorphism, and abstraction, and we have also implemented these concepts as well.